Dear students, in this lecture, we will learn two more methods of measuring dispersion. Number one is standard deviation and second one is coefficient of variation. Both these methods were given by Carl Pearson. Now, first we will study how to calculate the value of standard deviation. What is meant by standard deviation? It is a measure of dispersion. इसकी जो definition है वो ये है, it is a measure of dispersion of a set of data from its mean, or we can write from its average. It is a measure of dispersion. The concept of dispersion, this we have already discussed in previous lectures. Dispersion means spread out. That is how much a set of data is spread out from its average. How much variability is there in the given data from its average. And the definition of standard deviation, it is a measure of dispersion of set of data from its mean. It measures the absolute variability of given distribution, of given statistical series. इससे हम मेजर करते हैं एब्सोल्यूट वेरिएबिलिटी किसी भी स्टैटिस्टिकल सीरीज का. जो भी स्टैटिस्टिकल डेटा होगा, जब आप उस पे फार्मूला ऑफ स्टैंडर्ड डेविएशन अप्लाई करेंगे तो जो हमारा नतीजा होगा वो ये होगा कि हम मेजर कर सकते हैं एब्सोल्यूट वेरिएबिलिटी ऑफ दैट डेटा. नाउ proceeding ahead, we will now learn how to calculate value of standard deviation in case of three types of statistical series, starting from individual series. पहले हम individual series के बारे में पढ़ेंगे और हम किस तरह वैल्यू ऑफ स्टैंडर्ड डेविएशन निकालते हैं. The standard deviation, it is denoted by symbol sigma. And the formula of standard deviation in case of individual series is given as, first we will write the formula in case of direct method. In direct method, we get the value of standard deviation by applying this formula. Under root of sigma, here the sigma means summation of the values x minus x bar whole square, where x is any variable having different values, divided by n. And in case of shortcut method, or we can write indirect method, shortcut method or indirect method. Standard deviation, it is equal to under root of sigma d square divided by n minus sigma d divided by n whole square, where n, it shows the number of observations, number of items in a given statistical series in a given distribution, and d means deviations. This formula can be also written as under root of sigma x square divided by n, where this x square, it is equal to x minus x bar whole square, because in some books you will find the formula written in this form, so you may not get confused. Therefore, I have written both of these formula here. D is deviations and n is number of observations or number of items in a given series. And next topic is coefficient of variation, that we can also get from the same data, in which we can get the value of standard deviation. Coefficient of variation, it is also given by Carl Pearson, and it is denoted by symbol CV, coefficient of variation, and it is equal to standard deviation, value of standard deviation divided by value of mean multiplied by 100. It gives the percentage variation in a given set of data. Now we will do some example by applying this formula. फॉर एग्जाम्पल, हमारे पास ये डेटा है मार्कस इन हिस्ट्री ऑफ क्लास 11th, and the marks given are 20, 30, 40, 50 and 60. This is a statistical series, statistical data, from which we have to calculate standard deviation by applying direct method and indirect method, or we can say shortcut method, and we have to also calculate coefficient of variation. Now we will solve this example in this way. First we will apply डायरेक्ट मेथड. पहले हम डायरेक्ट मेथड अप्लाई करेंगे. इसका जो फॉर्मूला है वो ये है. standard deviation is equal to under root of sigma x minus x bar whole square divided by n. Now the variable given is Marcus in history, and this can be denoted by x. X is given as 20, 30, 40, 50 and 60. In the first column we will write the values of variable denoted by x. The values of x which shows the Marcus in history are given as 20, 30, 40, 50 and 60. 20, 30, 40, 50 and 60. Now next column will be x minus x bar, where x bar means arithmetic mean. First we have to calculate the value of arithmetic mean x bar, which is equal to sigma x, where sigma shows summation of x values, summation of values of variable x divided by n. X, it is equal to sigma x is equal to 200. 200 divided by n, number of observation, number of items in a given series, it is 1, 2, 3, 4 and 5. 200 divided by 5, it will be equal to 40. Now it will be equal to 20 minus 40, 30 minus 40, 40 minus 40, 50 minus 40, 60 minus 40. From these values of x, we have to subtract the value of arithmetic mean, which is equal to 40. It will be equal to minus 20, minus 10, 0. It will be 10. It will be equal to 20. And its summation will be equal to 0. Now as for formula, we have to construct one more column, that is x minus x bar whole square it will be equal to minus 20 whole square of minus 20. It will be equal to 400, 100, 0, 100, So this is 400, 100, 100 and 400. And summation of these values will be equal to 1000. Now therefore the value of standard deviation will be equal to under root of sigma x minus x bar whole square divided by n. It will be equal to sigma x minus x bar whole square. It is equal to 1000 divided by n is number of observation, number of items in a given series, which is equal to 5. 1, 2, 3, 4 and 5. That means marks of 5 students. It will be equal to under root of 200, which will be equal to, it is equal to 14.14. Now we will calculate the value of coefficient of variation. CV, coefficient of variation, which is equal to value of standard deviation divided by value of mean multiplied by 100. It will be equal to value of standard deviation, it is equal to 14.14, and value of arithmetic mean, it is equal to 40 multiplied by 100. It will be equal to, it is equal to 35.35. Now using the same data to get the value of standard deviation and coefficient of variation by applying indirect method, or we can say shortcut method. The data will remain same, however the method will be different. Shortcut method. Solution. Standard deviation, it will be equal to under root of sigma d square divided by n minus sigma d divided by n whole square. The formula is sigma d square divided by n minus whole square of sigma d divided by n, where d is equal to, d means deviation, it is equal to x minus a, where a is assumed mean, as you know, because we have already learned these concepts, these terms in case of arithmetic mean. Now these marks in history, it will be denoted by x, and the values are 20, 30, 40, 50 and 60. Now in the next column we will get the values of deviations, which is equal to values of variable x minus value of assumed mean. Then in the next column we will get the values of d square, which is equal to x minus a whole square. We can take any value from these values as assumed mean. Let us take 30 as assumed mean. It will be equal to the value of deviation. It will be equal to 20 minus 30, 30 minus 30, 40 minus 30, 50 minus 30, 60 minus 30. It will be equal to minus 10, 0, 10, 20, 30, and its square will be 100, 0, 100, 400 and 900. Sigma d, it will be equal to 50, and sigma d square, it will be equal to 1500. Now applying the formula of standard deviation, it will be equal to under root of sigma d square, it is equal to 1500 divided by n, number of observations, number of items in a given series, which is 1, 2, 3, 4 and 5, that is marks of 5 students, minus sigma d, it is equal to 50 divided by n is equal to 5 whole square. It will be equal to 300 minus divided by 25. It will be equal to 300 minus 100. It will be equal to under root of 200, which is equal to 14.14. We have got the same value as in case of the direct method. Because the data is same, the methods are different, the result should be same. Now we will calculate the value of coefficient of variation CV, coefficient of variation, which is equal to value of standard deviation divided by value of mean x bar multiplied by 100. We have got the value of standard deviation. Now we have to apply the value of arithmetic mean. Arithmetic mean, it is equal to, in case of shortcut method, in case of indirect method, it is equal to assumed mean is assumed mean plus sigma d divided by n. Assumed mean, which we have taken, equal to 30 plus sigma d, it is equal to 50 divided by n is equal to 5. 1, 2, 3, 4 and 5. Number of observation, number of items in a given series, it is equal to 5. It is equal to 30 plus 50 divided by 5, it is equal to 10. It will be equal to 40. Therefore, coefficient of variation, it will be equal to value of standard deviation divided by value of arithmetic mean x bar multiplied by 100. It will be equal to value of standard deviation, it is equal to 14.14 divided by value of arithmetic mean, which is equal to 40 multiplied by 100. It will be equal to by doing this on calculator, we will get the value equal to 35.35. This is how we calculate the value of standard deviation and coefficient of variation in case of individual series. I hope you have got. Thanks.